All right, so on this problem, again, I see there being a problem. It won't be one of the next videos, but this, I will be doing this at some point. It might be the next one. I just would say, hey, tell me everything you know. There might be like one final question that you have to solve for as well. And that way, if you can't solve for the final answer, you can get part credit by telling me the different pieces that you know from all of our lessons. This could just be like an exit ticket. At some point, we're going to stop. If you aren't here, I went through the calendar for the rest of the year pretty much and said, hey, this is when we're cutting off different dates. So we'll still do, after I cut off the date for doing new quizzes, which is pretty much Monday. I think next Monday is your last big quiz. So after that, it'll just be exit tickets. So this could be an exit ticket that and I'll tell you ahead of time, go back and review circle stuff. You're going to get a circles question or something, but this would be one that might be something like that. Oh, I didn't really freeze it. So let's see, who am I going to call on? Call on London. London, tell me something. And don't just say we have a circle. That's little. Tell me something that we've learned that relates to that figure. Take it easy. First person. That's probably, you can't come with a single thing, like, assuming that you had a conversation with Dad, so that's why I called on you first. Always going to be communicating. The fact that you can't tell me anything is an issue. Isaiah, what is anything? All right, so what are those called? Because again, that's still pretty obvious. Because it's something that we've learned. Anybody would know. Before you did these lessons, you'd see two lines. What are those two lines called? There's actually two names I'd be okay with, technically only one. Well, they're not, so let's talk about that. Wait, you said AD and which one? Yeah, so, well, AD and BC, right? So again, AD, so here's what I'll just show you. Following, Isaiah said these two lines are intersecting. So intersecting just means they cross. What would perpendicular mean? What is the word perpendicular? Means they'd be at a 90-degree angle, or those lines at a 90-degree angle, or those 90-degree angles form. Okay, so they're not perpendicular. So there aren't really any perpendicular things in this figure, but when is perpendicular a big deal? There was one lesson where I said this is the number one thing you need to get out of this lesson. Had to do with the lines being perpendicular. And when I tell you this is the one thing you need to get out of the lesson, you guys got to put some effort into remembering that. So I did this, and it actually was an accident, but I'm going to show you. I do this. I can't do it because I'm recording the shoot. So I set reminders for myself for different things that I'm trying to learn. Like there's this saying that I thought was kind of a cool saying. It's in Spanish. So I put a reminder, I put it in my calendar, and I make it go off now it goes off once a week, but it used to go off every single day. So the kids saw it in my calendar, like, why do you have that showing up every day? Because I want to remember. I put some effort into doing it. I don't just think, oh, that'd be great to remember that. Because that ain't gonna work. You can do the same thing. You're on your phones 24/7. You have, I'm sure, some app on your phone that has calendar in it, or an appointment, something, a reminder. Put it in there. Set it to repeat every day when you first get a lesson. So like when I tell you this is the number one thing you gotta know, put some effort into it. You guys complain, you say you try, you say you do this and that. You're not. You're not. Like don't say that. Unless you're truly doing things like that. Like I know most of you don't study that before quiz. So I'm almost giving up on that ever happening. But do something since you're on your phone all the time. Set it for 3 p.m. when you know you're gonna be your phone. And it would say that the 90-degree thing, do you know what it is? Sure. Not bathroom yet, but that's good. Oh yeah, you can grab that and go with it. So the 90-degree thing was a tangent line, and either the radius or diameter are perpendicular.
Grab what?
Was there one? I thought there was tissues on the desk. Oh, over there, you see them? So again, you're on your phones all the time. That would pop up every day when you know you're on your phone, 2:30 p.m., after school, whatever. It'll pop up. It'll remind you what that was. Very, very little effort, but actually probably would be something if you know every day that you would not forget, certainly not by the time you quiz. So you got to do stuff like that. Don't ever tell me you've tried unless you're taking steps. Some kind of steps, doesn't have to be that one. All right, so they're not perpendicular. What are they called? Does anybody remember what they're called? Actually, technically they're called something different because they actually continue on, but the highlighted part, we could say it's called something. Well, somebody else said they're congruent. We can't say they're congruent. Not yet. Turns out they are, but you can't just assume they're congruent. Because I can draw any two lines across, doesn't make them congruent. Normally they won't be congruent, actually. Actually, I don't even know if those are congruent, to tell you the truth. They would be in proportion, because that's one of the theorems we learned when we said the segment lengths. Like we could say, and this wasn't even something I expect you to remember, but we did it for the last quiz. This segment times this segment would equal that segment times that segment. They're in proportion, but yeah, I don't think they're congruent. Parallel. It is probably a parallel. No, actually, it's a trapezoid. But it probably would be an isosceles trapezoid. So I think we probably could prove they're congruent. There's nothing that just says two lines across are congruent, so we can't just immediately say that. So let's do the little things, and then we'll figure out that they are actually. What do you think? What? Yeah. So not both of them. So AD is a secant because it has one. Doesn't matter actually if that's on the line or not. It goes through the circle all the way through and passes. So what is it? What is AB called then? Shandy, you had your hand up. What's AB? That's a chord. So again, we said a chord, its endpoints are on the circle. A secant keeps going through the circle, and it could have gone off the circle that way too, or it could just go off the circle one way. AD, we would say, is a chord. If we just stopped right there, that's a chord also because its endpoint would be on it. But then if we said the ray or the line AD that keeps going, that's a secant. Again, that doesn't really affect any of the math. So that's not a huge one. I didn't spend a lot of time on that. Now let's talk about what's congruent. What did I tell you is congruent? That's the big, like if they give you information, the problem, if I give you information, that's pretty sharp. Like I'm telling you that for a reason. They're going to tell you information for a reason. So what I tell you? That would have been the easiest one. I'm sure she'd say exactly what I already told you. Tell it. What I tell you? AB. So I told you that, and what AB? What am I giving with the symbols? So the segment. They're line segments and arcs. So that line segment. I'm going to kind of get rid of the question now. We know what we mean. That line segment is congruent to that line segment. I told you that. That's fine if you tell me that. I don't, again, saying it's a circle is not really telling me anything. If you understand what that statement means, that is telling me something. Because you could have said part AB is congruent to part C. What's C? Again, telling me what the given information is fine. It's kind of like you're doing a proof, really. I mean, you're telling me what you know based on what's given, and then what can you prove step by step after. So now there's one we can prove now that we know the chords are congruent. There's one we can prove after that. I'm not going to call on for that. Ben, I'm saving you. There's Nayland. What do we know? You can either tell me what I'm kind of getting at, or if you know something else is true. What could we say maybe now that we understand that AB is congruent to CD segment? All right, so we actually didn't even need to know that these were congruent to say that, and they're congruent, they're not similar. The angles are congruent, typically shapes would be similar. So we can say that angle is congruent to that angle. Why can we say that? Yeah, it's two lines are crossing, the term was vertical angle. So we know those two angles are congruent. What else do we know right there then, Chloe? We said that's true, and we said those are vertical angles. What else would be true? Right in that same area. Again, if you can't tell me anything about this shape after a full lesson on a module, that's a problem. Yeah. If we have two lines that cross, there are two pairs of congruent angles. That's one of them, the two that are across from each other, basically. And then those two. Those are also congruent. That's not even circle stuff. That like goes way back to when we first started doing. Well, probably right after line segments, whatever. It was probably our second lesson after we named stuff. It's probably our second. When we first started angles. So again, there's some stuff you should know. It's not about circles, but that tells me that you retain some of the pieces of geometry that we've done. What's another one? There's still one that I'm trying to get at. That's more of our circle stuff. Israel. Again, it goes back to the information I gave you. I told you segment AB was congruent to segment CD. And those are chords. The very first theorem we learned under chords said that we know something else based on that. Well, that would actually not be true. Because if you look at it, this is shorter because that line goes up and out, that line goes down, which means this line's longer. Now there is something about those two lines we'll get to in a minute, but what? Oh, this was there, but I'll just give you the answer. Chance, this is good as there. If the core, so this was a big one. Again, this would be one to set a reminder on and just pop up in your phone over and over and over again, because it's one of the basic things you gotta know. Just like that perpendicular thing with a tangent and the radius or the diameter. If arcs, I'm sorry, well, actually it goes both ways, but I guess I'll do two. If two chords are congruent, their arcs are congruent. That's when you've got them. One to set a reminder over and over again until you just are like, I can't forget this. Seen it a million times. So if two chords, it doesn't matter where they are. I could have a chord here and kind of opposite side. I could have it here and next. If the two chords are congruent, then the arcs have to be congruent. And we didn't prove that out. We didn't really do a lot of proofs, but that was one of the theorems we learned. And it kind of makes sense because actually, maybe we did do it. I don't know. It would have to do with central angles. Like if the central angle measure was the same. So again, if we drew a central angle in and it hit those 2 points, and then we drew a central angle to those 2 points, there's no other way. Like the arcs are the same arcs, same measure of the angle. We have the same length chord at the end. So then we know a central angle matches, which we don't have a central angle. That's not the center of the circle there, but we know that a central angle is the same measure as its arc. Another one that you should have, like, you tell me something else? Oh, no. Well, tell me something else anyway. So now let's start looking at the arcs and the angles. So now we know two arcs are congruent. So from knowing two arcs are congruent, what else do we know? Some theorems about that. Arc AB is congruent to arc CD. So I'm going to get rid of some of that because otherwise it gets super cluttered. And I'm going to do this for you. That arc is congruent to that arc. Nope. I'm gonna help you through it. What did we learn? What kind of angles do we have in there? A lot of them. At point A, at point B, at point C, at point B, what kind of angles are those? Yeah, but again, that's just going back to like elementary school, cube, obtuse, that stuff. We learned something about angles when the vertex, because a point of an angle is typically going to be a vertex. When the vertex is on the circle, we learned a lot about that kind of angle. Chance started the word out. Is it outside the circle? So it's where? Sort of inside, right? The vertex is on the circle. Again, if you're struggling visually, I told you the pictures would get more difficult. What's that angle called? Is that one? Yeah. Inscribed angles. You got a whole bunch of inscribed angles. So again, you're not seeing this stuff. You haven't put a whole lot of work into these lessons. You don't see that there's some inscribed angles in there, because they're all over the place. Like I could say these big I could say these big angles are inscribed because they are. So that's inscribed. I could say there's a bunch of little angles. So that angle to that angle, basically any point you have with lines coming out of it is an angle. So all four of those points. Now, the only place we don't have inscribed angles is here. Why don't we have any inscribed angles there? Can you answer that, Rihanna? Why aren't there inscribed angles at E? Why am I not saying inscribed angles? Melissa. Oh, I need that one. Well, why aren't there's not another name of that? Why aren't there? They intersect, but what did we just say an inscribed angle? Where does the vertex have to be for it to be an inscribed? It's a point E on the circle. That's why there's no inscribed angles. The only time you have inscribed angles is when the vertex is the corner, where the angle comes out. If that isn't on the circle, then you can't have, it's not an inscribed angle. So because sometimes we had figures where lines meet outside the circle. So out here, there's your angle out there. Well, that's not inscribed, it's outside the circle. Sometimes we have angles where the lines meet inside the circle. Again, that's not inscribed, not on the circle. But as soon as you see a point that is on the circle, and then you have lines coming out of it, that's an inscribed angle. So you got a whole bunch of them because you got 4 points, and from each point, you got 3 lines coming out of it. So you got a ton of inscribed angles. So what was the number one thing we said? Again, this would have been a great reminder thing. I'm going to do that next year and have kids do that. What did we say about an inscribed angle relative to a part of the circle? How? Ben, good hand up. There. What did we say about inscribed angles? What was important about them? The map one. Other way around. The arc, so again, that's my inscribed angle up there. So that's the angle. This is the arc. We said that the angle times 2 equals the arc, or the arc divided by 2 equals the angle for inscribed angles. Again, that's when you have to know. All the I mean, there are really just 3 concepts that all the circle problems revolve around for the first few lessons. Then we get into stuff like the last lesson. It's a little trickier, but if you just knew those first 3 things, that being one of them, the fact that a central angle is the same as the measure of its arc, that being another one, and then probably the tangent line and the radius or diameter being perpendicular, those 3 things would probably get you through 75% of the circle questions. I mean, you'd have to be able to take it a step further, but those are the concepts. So we got a bunch of And I'm going super slow, but that's here, I'm gonna redraw. Oh no, that's fine. I didn't do it. Just a moment. So we've got a bunch of, again, I'm gonna go back to this. So that is congruent to this. We've got a bunch of inscribed angles. So every inscribed angle is half of its arc. So now it gets a little tougher again. Zoe, I want you to tell me an inscribed angle that matches with arc AB. So you'd use 3 letters, and then the vertex would be the middle letter. What angle matches with arc AB? Well, inscribed AEB would match, but it's not inscribed. I want an inscribed angle. So the vertex, the middle letter, has to be on the circle.
Oh, AC.
Yeah, so ACB, right? ACB matches up with arc AB. We just follow the arc back down to a point, and it matches up. We said we did that one bell work where I had a whole bunch of lines everywhere. We said just take the 2 endpoints, follow it down, and then try to get back to the other side. So ACD, but is that the only one? What's another one? Chloe, what's another one that matches up? Again, I just take the next line. I follow it down. And then can I get back to the arc? Yep, sure can. So that angle matches up. And there was a specific theorem on that. Let's do that. All right there. Give me sick. Somebody I think got me. I'm sort of sick earlier. So that, again, the red arc is the same as the blue, but I'm just kind of matching it up with the red angle. So if those 2 inscribed angles have the same arc, what's got to be true about the 2 inscribed angles? They're the same measure. If we have the same number here, the red and the blue are the same number, we know these angles are half of that number, then they've got to be the same number. So there was a whole separate theorem that said that if you have 2 angles that share an arc or intercept the same arc, I think is the way the book reads, then they are congruent. Well, yeah, they're congruent. If you just do the math, you can figure out they're congruent. That number is going to be the same for both the red and the blue angle. We take half of that number, then we're going to get the same number for those 2 angles. And then we got that all over the place because we have angles that share this arc right here. CAD. Which one did I say? That shared this one down here, right? So CAD share it. CBD shares it. So those 2 angles would be congruent. So we could start saying all kind of other angles are also congruent. Those angles are congruent. We actually have arcs over here. This arc over here has angles that share it. So if we said, well, let's travel from here down to here and back up. So this angle here, so CDA would be that angle. So again, it gets a little confusing, I know. But then I would just pick a different line and I would say, okay, well, CBA would also be congruent to that. So those 2 angles are congruent. So what winds up happening is you've got a ton of congruent angles. We were told we have a congruent line segment. So that part we did have to be told. And now we can prove what? You got a quiz on Monday, so today's a bad day to tune out. Try to hang in there. And then again, like I said, it's one of your last easy quizzes, probably. Ben, I'm going to come to you. Counting on Ben and Shandy. I'm counting. Well, Shandy, I don't know when you weren't here all year long, but you came in pretty early. Huh? You weren't here all the first semester. No, were you in here when we did congruent triangles? Well, I'm just gonna give it away. What can we prove? And We know all those angles are congruent. There's a ton of congruent angles. And we now know, well, not now, but we were given that those two lines are congruent. What would we be able to say? If anybody else knows, since I kind of gave it away, but what? Well, the angles are all congruent. Well, not all of them. You know, we showed there's a bunch of congruent angles. And then we showed one, or we were told one side is congruent. What could we then say? I'll give you a hint. It has 3 letters in it. They're abbreviations. There's not, doesn't spell out a word. Like it's not a word. It's an abbreviation of 3 letters. That's one of them. We could have also done, well, technically we can't do that one yet because we only know that one side is congruent. So we'd have to start with one of these. We could say that we have congruent triangles because we have angle, angle, side. That was one of the ways to prove it. Or because we have angle, side, angle. So when you think way back to triangles and proving congruence, there were 4 ways. Angle, angle, side. Angle, side, angle. We said side, 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 and side, angle, side. If those things are congruent, 2 angles in a row and then a side, an angle, a side, and then an angle, 3 sides are all congruent. 2 sides and the angle in between them. All 4, those are the only 4 ways to prove triangles are congruent. Well, we have that. We have an angle, a side, and an angle that we could prove were congruent. We actually could even say angle, angle, side, because we know these are congruent because of vertical angle. So there's all kind of ways we could have done it initially. But the key is we only knew one side was congruent. So we can't use these 2 yet. Once we've proven it, though, and we know that they're congruent, this leads, somebody said that they were congruent lines, that AD was congruent to BC. So now we would be able to say that because now we know we have congruent triangles, which means we could figure out that those lines are congruent from the congruent triangles. But there's not really a theorem that we can jump straight to that on. If you see that, that's good, because that would still help you. We would actually be able to say the only way all of that can happen is also if those lines are parallel. We can say that. So it turns out that that's actually an isosceles trapezoid. And I don't expect you to get all of those things, but I pick a number and I said, okay, they should be able to tell me 5 new things, like 5 things from concepts we've learned, not in saying that there's a circle there. It's not counted as a thing. You got to tell me the concepts we've learned. And then if you get 6, you're fine. If you get 5, you're fine. If you get 4, I take a little bit off. If you only come up with 1, then you lose them. So the more you can name out of that kind of problem, the better off you are. Don't have to necessarily get everything, but you need to get pretty much all. All right, so we went through that pretty slow, but that's because I cut out a lot of stuff that we were going to do on the quiz Monday. So, and that's important. Like understanding those different pieces, being able to see them is a big part of what we'll probably do exit ticket wise for the rest of the year, as well as your EOC, certainly. EOC, I've heard, is very, very heavy on circle stuff. All right, so I'll wake them. Oh, here your circle. If you're still going to do some retakes, some of you are definitely going to owe me tutoring, which I'm doing today after school. If you can't do it after school, you can always do it at either lunch. I have second lunch. You can either come to me or go to G2. If you don't have second lunch, you'd have to go to G2 first lunch, but you got a tutor if you got less than a 60. And I need something in writing. Tutoring doesn't mean you go in there and you just sit there. Like they need to tell me that you worked on something. You need to learn the material. Like that's the point of tutoring, not just you going in and sitting in a room and not doing it. So those are already in your IXL. The codes are there, so you don't have to write anything down. Just go into your IXL, look for anything that says circles, or about circles. I'll put some more in there for the new stuff we're doing. I haven't yet. That we did the other day, so that's good for the, oh, that's my saying that I told you I wanted to remember, no me gusta. There's some other stuff that's over here too that I have that goes off on the weekends that I wanted to learn. But that's the kind of stuff, it would be 0 effort on your part and it would definitely help you if you just saw that every single day. Right after a lesson, you type it in your phone, and then you see it every single day, and it would remind you. All right, so here's where we're at. So turn to page 265. I mean, it's first page. I guess you don't have to turn to it. All right, page 265. So the good news about this next lesson, besides the fact that I cut some stuff out for the quiz, is that you've seen a lot of this stuff before. We'll do a little bit more with it today, but you've seen these shapes, like a parallelogram is not new, a trapezoid is not new. We did a whole lesson on these shapes. So the shapes themselves are not new. We're just learning a new piece, sort of. It's not even that really new a piece. So a parallelogram, I didn't really review this in the other classes, but since I'm recording, I might. What's true about a parallelogram? Dan, I don't remember where you famous, so let's see what you remember. What's true about a parallelogram? Were you in here when we did it? So based on the name, like, what do you think is probably true? Yeah, so a parallelogram means you got two pairs of parallel sides. So that's what these symbols mean. And you'll see them differently. Like I typically don't fill them in. If I were drawing it, oh, that one was parallel. I would just draw them like that. I don't color the arrow in, same thing. And a lot of times that's the way worksheets will be. I don't know how the EOC is going to do it. So just understand, anytime you have arrows like that in the middle of a line, it means the lines are parallel, assuming it's on two lines on the opposite side. So that means these two lines are parallel, top and bottom. The fact that those have two arrows means those are the two lines that are parallel. That's what makes it a parallelogram. And there were ways to prove that. I'm not going to go over all those today. We might review that down the road. But here's a big one you need to know. Opposite, if you know you have a parallelogram, opposite angles are congruent. So those two angles are congruent. These two angles are congruent. That is only for a parallelogram. So some of you on the two quizzes ago, you set angles equal to each other that were opposite. You can't say that unless you, and it was clearly not a parallelogram. And they were clearly not congruent. Like a figure looks something like this. It was four-sided, but this angle here is clearly not congruent to that opposite angle over there. It wasn't that exaggerated, but it was exaggerated enough where you should have seen that they are not congruent angles. So again, the only way that works is if you have a parallelogram. Top and bottom are parallel, left and right are parallel. All right, so here's the new piece. So I don't think we really had any problems like this, but there's a measure that we are going to need. We're finding the area of polygons. Yeah, area, well, in this case, specifically the area of a parallelogram, but areas of quadrilaterals, so not all polygons, just four-sided figures. So the good news is you get the first two, you get the formula on the reference sheet. You don't have to know, or you don't have to memorize the formula, but you will not be given all of the information you need in the formula. You have to figure it out. Dan, you up? Pardon you two names. How? Oh my goodness, how am I down? Don't see this part. Because there's your exit ticket. Yeah, oh, you have an exit ticket today. That much. Wake up, you got an exit ticket, and I'm about to go over it. Isaiah. Wake up. I'm about to go over your exit ticket stuff, so everybody wake up. So you're going to get a formula. We did this the other day. This isn't new, but I'm doing it again since I cut some stuff out. We have time. If you have a parallelogram, we said that the area of a parallelogram, and again, I'll give you the formulas, is equal to the base times the height. The problem is we don't have the height most of the time in these kind of problems. Put your phone up, girl. What did we say is the height is? Like, what's the height? Like, there's something specific about the height. Why don't we have the height in this figure? Like, why can't we just say, well, that's the height right there? If we had no, like, I'll put it. So what does the height have to be? What's the word? 90-degree, or I don't know if you were saying the word, but I'll say it. Perpendicular. The height has to be perpendicular to the base. So we can't just use this 10 and definitely not the 11. 11 would be the base. And then if that's 11, so here again about parallelograms, opposite sides are also congruent. So opposite angles are congruent, opposite sides are congruent. I didn't mention. So I can't just say 10 times 11. So it's not going to be quite that easy. So normally they'll do this for you, like you see what they did here. They drew in a dotted line at a 90-degree angle to tell you that's the line you need. That's your height right there. You don't even have to remember to do that. At least not on the problems that I've seen and not on your exit ticket and not on your quiz. I went ahead and I drew in the thing that you need. You just got to know how to figure it out. So what is it that we need to figure out? I'll draw it in. Oh, it doesn't have to be inside the circle either, we said. So it could be outside the shape. Like I could draw it in out there. And you got to know, okay, I need that dashed line going up and down. And it could go left and right. So, because remember, I could always turn this figure sideways and now that line's going left and right. Or we could draw a different line in that goes up and down if I turn it sideways. That would be possible. But the key is, what is it that I need to understand about? And I would have one more piece of information. I'm not going to tell you that part yet. What is it that we needed to understand or are going to need to do, we said? We did this the other day. Say it again. Yeah, we have a right triangle. And again, I've said this since the first time we mentioned right triangles. Anytime you have a right triangle, so they would have to tell us maybe that this was 2 here or something like that. That'd probably be bigger than that. Because if that's 11 up there, this is probably closer to a third of that. So that would be 3. They probably wouldn't give us that at all. If it was a true problem, they would just tell us that. So you have to say, okay, well, wait a minute. I can't use the 10 and just multiply it times 11 because 10 is not a height. It's slanted. So I need to figure out this line. I have a 3 here. What else do I have with that right triangle? 10. Yeah, I know the 10 is this line. I'd written it a second ago and I erased it, but that's still the 10. That line is the same as the other side. We just said that for a parallelogram. So again, you would have to be told that they're it's a parallelogram. Technically. So I can say if I have 2 of the 3 sides of a right triangle, I can solve for the third side. And we're not even going to worry about it because we got something else we're going to do that's tougher. That's when we would do that. Which one is the important side out of the numbers I gave you? The 3, the 10, then one of them's an X. 10 is what? Yeah, perfect. We know the hypotenuse will always be across from the right angle, which will be drawn in for you, at least on what I do. I don't know about the EOC. So if I know that's 10, I can do it down here. We're not going to finish the math out, but then that side C, I'm solving for one of the legs. It doesn't matter whether you make that A or B, and then 3 would be the other one. And now we just solve out and figure out what X is. Then once we solve for X, that is our height. We use that number for the H. What is the base number we would use? Yeah, 11 would be our base. Percent. Oh, that's X. Okay, so X would be 9.54 if you did the math. The base, so again, that would be the height. The base would be the 11 that they gave us. But be careful because some kids were using the wrong numbers for the base even. If there's two numbers down here, don't add them together. Like if they had also written 11 down here. So if they had also written in the 11 there and then the 3 over there, don't add the 3. The 3 is not part of the figure. So it can't be the base. It's not part of the base. The base is one of the sides of the figure. Only use from one vertex to one vertex. So we would say 11 times the 9.54, which we would solve. The way we got 9.54 is solving this for x, and that's your area. Again, the formula itself is not complex. It's knowing what to do to get the number you need, the height part. It's the little bit more complex one. And that's pretty much what you do on your exit tickets. We also are going to have some more complex problems. I don't remember how much of this we did in class, but so we said we're going to need to use some trigonometry sometimes also. So I want you to try this because this is your Monday quiz. So this is problem number 2, example number 2. If I have a parallelogram, and how many sides do I need to do a squared, b squared, c squared to be able to solve? I need 2, right? I can only solve if there's only one variable in an equation. So if I don't know 2 of the sides, I can't do it. But if I know one of the angles in a side, that's when we did our trigonometry. We said if we have a right triangle and we know angles in there, we said the sine is the opposite over the hypotenuse. Cosine is the adjacent. And these are the lengths, if you remember. So over the hypotenuse, and tangent was what? Yep, TOA was, oh, it didn't really work out very well. So tangent was opposite over adjacent. You don't have to memorize those. Those are on your reference sheet. I'm not going to spend a lot of time on memorizing those, but you did need to understand when we figure those out and when we're going to try to solve everything, like we have to create the problem based on what? Like what's our focus? Creating problem. What's the important thing to, like everything stems from this part of the figure. Well, both of those. So the angle is what's important. Sometimes they might give you the angle like they did here. Sometimes the angle might be what you're solving. Now, in these problems, when you're finding area, they're probably going to give you the angle every time. There's no reason to solve for an angle if you're solving for the area of the figure. So in these particular problems, you're pretty much always going to be solving for the side. So what this means, oh, I need to put that in. That symbol means angle if you don't remember what that symbol means. So we take either the sine, cosine, or tangent of the angle. That gives us a decimal. We set that equal to the proportion of the side that we have and the side that we want, the side that we don't know. So in this case, we need the height. So our x would be that guy that's going up and down in the picture. And then we can solve for the x. So I want you to try to do that one on your own. So again, I'll zoom in, but you have it in your book, probably easier to look in your book. You need to use what they did. Well, actually, they did it a different way. Don't look at what they did. Try to solve it using trig, not what they're doing. Ah, shoot. Can't really zoom in anymore. So just look at your book. Try to do it this way. I'm going to tell you the other way, but we're trying to combine practice two different things into one, so we go a little faster. So try to do it using the correct formula. Oh, so we said once we know which angle, so let's say this is the angle here. Well, then that means this is the opposite side. The hypotenuse is always the same. We can label that no matter what. And this is the adjacent side. We always label the sides from the angle that they give us, or if we're solving for the angle we're solving. So for this is the one they give us, that's opposite, that's adjacent. So you see in your picture which one they gave you, so then label it and then do the math and see if you can solve for X. I'm gonna get rid of this in a second. I'm not gonna pass out the sheet, so if you don't know these, write them down real quick, because you're gonna do a couple of problems with it. That's on your Monday quiz. You have to use trig on the Monday quiz. That's gonna be the hardest part of it. It's not super hard. I don't think it's a super difficult quiz, but it's not gonna be something you know how to do if you don't practice anything. Unless you just really remember how to do it. Well, I'm gonna do attendance manually, I guess, while you do that. To 65, maybe 65 or 66. 66. I think I already did. Yeah, I did do it before I started. Okay. Oh, I just made that up. I'm not the one I drew. I just made that up to show you if this is the angle they give us, then this would be the opposite side and this would be the adjacent side. If they would have given us that angle, this would have been opposite, that would have been adjacent. So you have to make sure you label it based on the angle that they give you, or if that's what you're solving for, the angle you're solving for. That's all I was saying. Yeah, that has nothing to do with the problem. This was not, this was just to show you how to use the formulas. I want you to then do that with the problem over there. I'm actually going to get rid of it anyway, because I'm going to zoom in, and this will go away anyway when I zoom in, so it won't matter. That's all I can zoom in, though. That'll be fine. Did everybody get their slips for when they test? They gave those out this week, so they gave new ones out. So if you didn't get it this week, you may want to make sure you get it, because it might be different than what you got a long time ago. There were some mistakes on them. So it looks like people are either not doing it or they're done. So I'll give you another 30 seconds. If you're not done, again, you can follow along and try to check on your own. All right. Sandy, can you see that all those numbers up there? Yeah, they're in your book. If you. Anybody leave this in class? Here after one class, I don't know. All right, so we're going to go through the process. Again, this is on your quiz Monday. Probably the most difficult thing, arguably. So if you got this down, you're in good shape. There's one that might be it's the same concept, it's just a little trickier, but still trig. So I need to think, first thing, what is important? What did I say is important? Everything flows from this first step. If you don't do this first step, might not get it right. What is important? So I gotta go there. I would call so-called Sade right now. She is not. Demarcus. What's the first step? What did I say? Everything flows from. You gotta understand this first. What's that? Well, it is 90 degrees. That's what allows us to do trig, because we can only do trig. Well, actually, that's not completely true. What we've only learned how to do trig with right triangles. So it's got to be a right triangle, or we can't do it. But once I understand I can use trig, what do I need to focus on? What's my first? Not really a step. You just need to understand this determines everything you do. Tans. So It all flows from the angle that either they give you, which in this case, they gave us an angle, or sometimes the angle, like this is really more for the other trig problems that we did in the past. Sometimes you have to solve for the angle. So if we know that's 45, every side that we label is based on the fact that we're using 45 as our angle. So if the 45 is right there, I actually don't want to cover that up, so I'll get rid of it now. What the hypotenuse is always the same. Where's the hypotenuse? Yeah, so we know that, right? That never changes. So we can go ahead and label that. If that's the right angle that I just drew in, across from that is hypotenuse. That'll always be the same. We don't ever have to worry about that one changing. So now from the 45, so, oh, what are we solving for? Let's write that in. So that way I can use these. What do we need? Like, what's the, we're doing area. So what, we have some information, obviously, but what is it that we're trying to solve for? Yeah, we need the height, which is which line? Yeah, the dashed line, right? Wherever you see the dashed line in the right angle, that's typically going to be your height. Now, sometimes there'll be two dashed lines, like be careful. If they do that, we're not solving for this section, the bottom section down here. We're not solving for that. We're solving for the one that is the vertical one, perpendicular to the other, to the base. So just make sure you understand which line is the height. This one's pretty easy when it's inside the figure. So we're solving for this one over here. So we'll make that X. And we're solving for the length of it, so it's not in degrees. So now, relative to that 45-degree angle, what is the X? Which side is the X? It's not the hypotenuse because we already labeled that. It's opposite, right? It's across from the 45. So X is the opposite side. So we already know where the hypotenuse is. So what does the 9 have to be then? Got to be the adjacent. That's the only side left. And adjacent means next to. So the 45 is right next to that 9. 9 is actually one of the sides that make up that angle. So this is adjacent. So that's your first step. Now we're ready to set up a formula or an equation. But we got to figure out which function are we going to use. And the way you do that is you take the sides that either have the information you're going to use or they have the side you're solving for, the variable. So which sides have the information we're going to use or we're solving for? How, since you're up now. Which sides have the information we're going to use or that we need to solve for? The what? So do we have information where the hypotenuse is? Number there. So here's the hypotenuse, right? Do I have any numbers there? I don't have a side over here. I don't have any numbers there. Do I need to solve for the hypotenuse? Is that my variable? No, right? The X we wrote over there. So am I going to use the hypotenuse in my formula? Oh, so be careful. That's why I say you need to tune in because this is on your quiz. So what do we have for formula? Yeah, we need the opposite. So we're going to have the opposite in there somewhere. We have the adjacent. So we're going to use the adjacent. So which formula uses opposite and adjacent? Which function really? Something. Tangent. Tangent is opposite over adjacent. So I can kind of move this under here because that's going to be the formula. I know that's the tangent of the angle equals that. Now I just plug stuff in. So what is the angle? Tangent of what? Yeah, it's the angle they gave us. It's always going to be the angle they gave you. You just plug that number in. That's going to equal, what is the opposite side? What do I put for opposite? Yeah, that's my variable. That's what I'm solving for. I need to know what the length of the opposite side is. And what is my adjacent? Brianna, what's my adjacent side? What I'll put there. All right. So that's my equation. Now I want you to try to solve it. Oh, shoot. Don't let me forget about starting the exit ticket with 6 minutes. So right at about 30 minutes. Oh, that's right. We go for a full 2 hours. Oh, we got tons of time today. Oh my goodness, that's me. So we can go for a lesson forever in here. Bro, we can go for a lesson forever in here, bro. I could have let you guys nap for like 15, 20 minutes, woken everybody up, and get started. Yeah. Should have done that. You guys nap for 20 minutes, and then I'll wake you all up, and then we'll start. So you'll be rested. After your nap, I can't now. Like I wouldn't be able to fall asleep. No way. Especially not because like I can't fall asleep like unless I'm like sick and I don't feel well or something. I'm super tired. There'd be no way, even in the morning, I can just like put my head down and fall asleep. I probably couldn't fall asleep in an hour. I got to be super comfortable. It's gonna be dark. So you should be done. Not super complex math. You probably will be like, whoa, is that the right answer? That doesn't make sense. Whoa, that seems too easy. Was easy. I want you to do it. We're going to go over the easy way. So what'd you get? Adam, what'd you get? That's the problem right there. That's also why you think discovering things about you don't know. We need to fix the root problem, not the saying like we're putting a band-aid on it. We need to like stop you from bleeding. Not worry about just put band-aid on it. Get your work in class, not just trying to fix it with tutoring. Retakes. What's tangent of 45? 1, right? And then what do we do to solve for x if we know that's 1? And what do we get? Isn't that kind of weird? Or is it? You notice anything about that triangle that we had? It is a special right triangle, isn't it? If we know we have a 90-degree angle there, 45-degree angle there, what's the other angle? It's got to also be 45, right? Is anybody writing any of that down? So let me show you another way. And sometimes, and I would expect the EOC to do this, they aren't really testing your knowledge of trig sometimes, even though you can do it using the full trig process. They're testing your knowledge of special right triangles. And that's what this is. I'm going to draw it a little bit larger. So we know that's 45. We knew that was 90. Well, again, all triangle or the interior angles of all triangles have to add up to what? 180. So we know that's got to be 45. Because 45 plus 45 is 90, and then plus 90 is the 180. Well, that brings into play that whole special triangle thing, or even really just this. What is this? That's not a very good drawing of it, but what kind of triangle is that? So what else do we know if we know those two angles are congruent? Drawing. Well, we said if we know it's two base angles are congruent, we knew something else was true. Where are you going? Class. Seems kind of goofy. What do we know about an isosceles triangle? We know those two base angles are congruent, and we know sides are congruent. And the opposite is true. If we know the sides are congruent, we know the two base angles are congruent. That's a definition of an isosceles triangle. So what do we know here? If we know these two angles are congruent, what do we know? Same thing. What do we know? What did we just say down there? Same thing. We know the two angles are congruent. We know these sides are congruent. That's an automatic thing. That would have been a great reminder back when we did that lesson. If two angles are congruent, then their two sides are congruent. There's a little more to it than that, but that would at least remind you of what you're trying to remember. Didn't we know one of the sides? We knew this was 9, right? So did we need to do any math at all? No. If you knew your past lessons, you'd be like, well, wait a minute. I don't need to do trig, even though it says trig. I know that's an isosceles triangle. Well, I know the other side has to be 9. So I didn't want you to do it that way because I wanted to go through that process of trig, because on the quiz, you have to do the trig. I don't give you a special right triangle. So make sure you practice that on the problems. I don't know what the practice problems are like, if they are all special right triangles or not. But make sure you practice it the trig way, because that'll always work. You won't always have, why does that? You won't always have a special right triangle. If you happen to notice that, great, but you need to know how to do it the trig way and solve for the length of a side. Oh, that's right. I zoomed in. So go ahead, try to do the check problem. Give you like 4 minutes. So that's there. That's the check problem right there. It's in your book, so you don't have to look at it. I mean, if you want to look at it up here, down here. Are you gonna do it if I bring you a marker, Marcus? Chance. You want a marker? Anybody else rather just do it at the desk? Oh no. Yeah, I had a student that was sick on Monday and came in just because we had the quiz. And then I started to feel sick Tuesday. But then I slept a lot, went home and took naps both days, and got to bed early, so I feel okay today. But now you just told me the Oh, the formulas? You need formulas? I'm just gonna, what do we need? Where this is our angle, we know this is our x over here. Let's just do that part together, and I'll just put the correct formula. What function are we gonna use? Where is this, like, what is this side? The 12 we know, so we're gonna use that. It's the opposite, right? If we're using that angle, that's opposite. We need to solve for x, so what is the x? So it's adjacent and opposite again, so what form or what function are we going to use if it's adjacent and opposite? So tangent. So tangent of the angle equals opposite over adjacent. The same one we used, and that'll be a pretty common one for these types of problems. Because if they give you the hypotenuse, you're normally going to be able to do a squared, b squared, c squared. So you wouldn't even need to do it if you knew the hypotenuse. And I think there's a question pretty much just like this on your quiz next Monday. You can do this. You should be in pretty good shape. Still say look it over again Sunday, but oh, and don't forget we're doing the area. So once you solve for the height, you're not done. Okay, do the area. Give you another minute, and then we'll solve it out together, and then I probably will start. I won't do as much as I did in the other classes. I'll just start the next lesson after we do a trapezoid. Trapezoid is kind of the same exact stuff, just different shape, different formula for the area, but you need to at least try one or two. That means your question. I guess I can look at it. We're about to solve it out. Sure, so we got that. For that. So what would you do? Yes, you would. What if it was this bone? Actually, I'll do it. So if you're struggling a little bit to solve, because it does look a little weird, if you had this, what would you do to solve that? Divide by 2, right? I need to get x by itself. So if this is multiplied times x, I divide by 2. So you've got a weird number there instead of 2, but it's still the same concept. And then just make sure you kind of get a number that makes sense, because it shouldn't be longer than the hypotenuse, right? Oh, actually, we don't know the hypotenuse, so I guess that doesn't mean. It gets so bad. I'm never just going to tell you an answer because I won't fit. You need to think about it and figure it out. Hold on to your calculator. Yeah. Kids. I made a girl so mad in 7th period for that same reason. Like, she just wants somebody to tell her the answers. I won't do it. Stop doing it. All right, so quickly, I'm going to do it fast. So we know already which side is which. We've done really the, not that it's difficult, but we've done the part that's the important part. Now we just plug stuff in. So we would say tangent of 30 equals opposite we said was 12. Adjacent we said was x. If you take the tangent of 30, I'm going to round it off. We get that 12 over x. Again, this, and I love the fact that you did do cross multiplying on it. I would say cross multiplying is a much easier way for these kind of problems, mainly because if we get an x on the bottom, it's a little trickier to try to figure out what we need to do. But if I just say, well, that's just like being over 1. So I multiply those two together, set them equal to those two, and I get 12 equals 0.577x. Again, that's why I did the whole 2x equals 6 thing. It's the same math. This means I'm multiplying these two things together. So I need to do the opposite to get rid of it and divide by it. Well, if I divide by it there, I need to divide by it there. What do you get when you do that? There you go. So now we know the height is 20.79.8 or wherever you rounded. So now what is the base? I just need to, for the area, I just have 5 times the base. Area is going to equal 20.79 times what? Yeah, it's just, remember, make sure you only do a side. Use the side. So that is the side that would be the base. What do you get for your final answer then? That those two times each other is what, 600 something? Somewhere around there. And remember, we said, don't worry about this m squared thing. Just when you're finding area, that's the way you show the units. Like if you're just measuring something, that's meters. M is a meters. Means meters, not very old. So when you're measuring something and you're just finding the length, you just say this many meters long. But when you're finding the area, you say meters squared because there's a length and a width, not just length. And then if it was volume, you'd actually say meters cubed. Really quickly, we got to go super fast. We may not even get to the brand new stuff. Oh my God, I keep saying it. So yeah, so we got a long time. So what time do we get out? 9:30 exactly? Oh, all right. So we've got another 45 minutes. 45 minutes, right? It was only 8:45. Oh, then bring that phone. No, we should have done that. Maybe you can have, maybe we'll do it early if I feel like everybody's ready. Yeah. Or maybe I can like phone if I feel like everybody does well. Then Camila can actually use her phone legally instead of Instead of using your watch and your phone, let's put on your desk. I'm gonna say, do we want to build in some free time at the end, or do you want to have more time to practice? All right. Majority vote. Raise your hand if you want to build in free time at the end for napping, or if you pay attention and put effort in, I'll let you use phones. Raise your hand. If you want it, you better raise your hand, because otherwise, if other people bet, all right, that's going to be the majority. Don't need to ask the other version. So how much time? We need at least 20 minutes, then 5. So, well, I'll just put how much time. That's how much time is left in the class. When you guys think you're ready, after I get through everything, if you want to practice, you can practice for a second. If everybody's like, no, let's just do it, then we'll just do it. All right, so trapezoid is the same concept. We do the exact same thing. There's going to be the need to figure out the height, just like we figured out the height in a parallelogram. You can look at the picture. That's probably 267. Is that right? Is that no? Right? I don't know why I can't scroll over, but we'll just do this. Yeah, 267. So again, it's the same concept. We're gonna. I didn't say this, but just so you know, the height, by the way, does not have to be from a vertex down to the other side. Like this is also the height. Like the height is in the middle as well. Like any line that is perpendicular is the height. So why don't they draw in the height in the middle instead of why do they always draw it in way over toward the end where there's a vertex? Why wouldn't they just draw the height in the middle? If that could also be the height. Makes more sense maybe in the middle. If it's in the middle of the figure, that's easier to understand. But why does that not help us? Yeah, we can't do any math with that. There's no right triangle there. We have to draw it from a vertex to make a right triangle, to make corners, vertices. We draw it right down the middle, we create two trapezoids, which doesn't really do us any good. Same thing here. We're going to draw a line in that's the height and create a right triangle. We're going to do the exact same thing to solve for the height that we just did with parallelogram. The only difference is there's a different formula. When we figure the height out, we use that formula to figure the area of the trapezoid. Now this one is a little different problem. So you don't solve for a height in this one. I don't have anything on the quiz like that, but go ahead and try to do it. So you're doing example 3. They give you everything you need in that formula. So I want you to try to figure out it's a word problem. I want you to try to figure out it's not tricky, but just what is the part you have to understand in order to do that problem. We don't have to solve for the height. They give you that if you look at the picture, the little garden picture thing. So I'll give you guys a couple minutes to work on that. And then I want to try to find one where it's solving height. That's on. You could also have to do trig with trapezoids. So just like everything's the same as what we just did. It's just your final formula would be different if it's a trapezoid. Staple it. I'll just keep that on the table and push down hard. It should fill. Make sure it's not sharp on the other side. Sometimes they're still want to knock those down a little bit so they're not super sharp. We're doing an example 3 on 267. It's just a different formula. And they've actually given you everything in this formula. You don't even have to solve for the height or anything in this particular problem. You got to work if you want to get nap time. Or do nothing. That's the deal. If you guys work, Nap time, otherwise we'll work all the way through it. Oh, and Hal's got his phone out. He's making a bunch of mistakes. He's sleeping and he's not working. And he's on his phone. Oh, you gotta work. You want nap time, you gotta work. Work. Looking for the next. Yeah. That works for the next 15 to 20 minutes, then do your exit ticket, then you got 15 to 20 to just sit there and do sleep, even phones. Whatever you want. You could actually study for Monday and sit back. Slam to none on that, right? Whoa. Bro. Work. I know you haven't done this one yet. You see what the check flow is. Yeah, I don't really wait. Let me see what. Yeah, I don't really even care about you doing the check problem on this one. Actually, we'll just do that. I'll just do the new piece after we do this one, and then yes. You know, I was trying to think of it. I think it will be because if you had the hypotenuse, which is what you would use for sine and cosine, then the odds are you'd just be able to do a squared, b squared, c squared. You wouldn't need trig. So I think most of the time in these problems, you probably, if you have to do trig, you're probably going to be doing tangent almost every time. Otherwise, if they gave you the hypotenuse, you'd just be doing a squared, b squared, c squared. I couldn't think of a time when that wouldn't happen. I mean, I'm sure it's possible. I don't remember what I put on the place. Oh shoot, there is one that I got to show you. Wow, sorry about that. Tell you what, you guys work on that. I'm gonna put a problem up. You have it in your book pages, so I'm just gonna create it on a new page. Yeah.
We're gonna start the next tick at 6.
Yeah, like before that'll be the last part, and then after that we're completely done. You can do whatever you want after that. I'm not gonna let you nap and then I'm not gonna try to wake you up and then do an exit. That won't go well, I'm sure. So let's draw. I guess I could do it. With a parallelogram. So this is also on your quiz. So I do need to show this to you. Probably should have drawn that bigger. I think I can probably still make it. Yeah. There. Oh, yeah. There we go. What's that? Maybe that's probably. Yeah, it's actually probably pretty good. So if you get done with the one in the book and want to jump straight to that, you need to try that. Oh wait, yeah, I do that. Oh, okay. So what was your answer for this one? Well, read what they're asking for. You have the correct math, but make sure you read what they're asking for. Final answer. One more step. So I'm going to go to the other problem. If you're starting this one, just quickly write down anything you need. So I'm going to get rid of it in like 30 seconds. Area again. Sorry, area. Still area. Well, I want the area. You got it. Because what I'm saying, you got to know when I say solve for the area, you got to know what do I need then. So you will get the formula. So I'll write the formula. So this is But I can't, that's what I'm saying. I can't, that won't be on the quiz. That's the part you have to. So if you need these two things, right? Mila, if you need these two things, one of them you have. Oh, wait, actually, no, you don't. I'm sorry. This isn't the one I wanted. So, yeah. Sorry, that was my mistake. So that would be 15. That should have been up there. Different. So ignore the 10. The 10 wasn't part of it. So if you were already starting, I think a couple of you started, 10 would not have been given to you. You would have had something like that. So one of those variables you have, you need to know which piece of this figure is the other variable. And that's the one you would have to solve for. All right, so we're going to come back to that in a second. All right, so on that other problem, oh boy, now I gotta find it. So like I said, they gave you everything you needed. It wasn't about trying to do trig or even a squared, b squared, c squared. They gave you the height. So if we have that trapezoid, it kind of sort of looks maybe something like this. I'm going to erase that and from that formula. So they say the height, and I don't even know where they drew it, but let's say they drew it, even if it's in the middle, it doesn't matter. Just as long as you know that's a right angle, you know that dashed line would be the height. So what's the height? Actually can't see it. What is the height? 7. So that height is 7. So the top, again, a trapezoid has two bases. Top side is a base. The two parallel sides basically are the bases. Turn sideways, it's the left and the right, but the two parallel sides, which they don't tell you, like they don't draw in these arrows, but they tell you it's a trapezoid. That's how you know there's two parallel sides. So the top one they say is 1.5, bottom one is 8. So you have everything you need. You have the height, you have the base 1, you have the base 2. The area part of this problem is not the difficult part. The difficult part is answering their final question. So all you have to do is plug into a formula. Be careful. A lot of students were just getting this wrong because they did calculator mistake. If you're going to try to plug it all in at once, you got to make sure you use the parentheses correctly. Basically, you do just exactly what you see in the equation. You got to put a parenthesis around, I can zoom in at least a little bit. You've got to put parentheses around that base 1 plus base 2 if you're going to try to plug everything in at once. But don't do that, you'll get the wrong answer. Safe way would just be to figure out base 1 plus base 2 on your own and just use that number and then just multiply 3 things together. So area equals 1/2. What's the height? Height is the perpendicular part, right? Always. Height is the perpendicular part. 7. And then, like I said, I'm going to put parentheses around it. I'm going to write pretty small. 1.5. I don't know why I wrote 1.8. 1.5 plus 8. Again, I would just go ahead and add those two together first and just have one number instead of trying to worry about putting it in the calculator correctly. So now if you do the math, you're saying 1/2 times 7 times 9.5, which is what I would do in the calculator. I wouldn't worry about trying to break up the two bases. And what do we get? 3.5 times 9.5. So what's that come out to be? Somewhere around. So 33 point what? Yeah, I'll just write it here. So the area we say is 33 point around 525. Is that what you said? Oh, 0.2. All right. So if we know that's how much space we have to cover, that's what area is. The space we're covering, space inside a shape. The question is actually how many bags of mults, we would need to buy. There's a bunch of ways to do it. You could say, well, I know one bag is 12 square feet. So that doesn't cover it, right? One bag doesn't cover it. I got to cover 33 square feet. So how much would two bags cover? 24, right? Does that cover it? Oh, I still haven't covered it. How much would three bags cover? Did that cover it? So I need three bags. So one way is just to do it like that. Take the bags and keep adding bags till you've covered the amount you need to cover. Another way to do it is what, Chance, I heard you say. What'd you do? Yeah, I could say, well, how many bags would I need to cover that? So I would divide that by 12. So if I divide that by 12, you get a decimal like 2.77, but we can't buy a 0.77th of a bag. So we'd have to buy a full third bag. So you get the same answer. Somebody else did it a totally different way where they said, well, I'll just subtract 12 out and see how much space is left. Because 12 square feet is one bag. So if I put one bag down, how much space is still left? And then she needed to subtract another one, and then she needed to subtract a third one to finally cover it all. Kind of the same thing we did on the first way, where we added 12 plus 12 plus 12. So again, that was not a problem like the parallelograms that we did, but on the quiz, I give you a trapezoid problem that's like the parallelogram problem, where you have to solve for the height, and then you just, once you solve for the height, you just plug it in the formula and you find the area. There's no word problems on the quiz, just pretty much same kind of stuff we did over here. I don't remember if there's a trig. I think there is a trig problem with a trapezoid too. So I think there's two trig problems on there. So make sure you understand how to do the trig stuff. Really quickly, let's do this one and then probably time for your exit ticket. So there's a key. We won't finish this one all the way out, but there's something you got to recognize. I need to solve for x. Where would I put x? I need to solve for the height. Where's the x go? Where's the height? Yeah, it's going to be a dotted line, right? That's almost a given. Well, it can't be this. That line is not perpendicular to one of the bases. This line is the line that's perpendicular. So that's my x. Now I need to say, okay, well, let me label things. Here's where you got to be careful. What is the angle that I'm using? Is it? That's the part that caught every single person yesterday. Is it? Where's my right triangle? No, we can't use the 90. So that's why I said this one's a little tricky. And it is, I believe, on your quiz. Actually, I know it's on your quiz. That's my right triangle, right? Is 70 in that triangle? I can't use the 90. We never use a 90-degree angle to do sine. So what do I need to do? Yeah, I've got to solve for the angle that's inside the right triangle. I need to say, okay, well, if that's 70, if this is a right angle, I know that's actually also a right angle. This whole angle here would be a right angle as well. So if I know part of that is 70, I know the other part, the part that I need that's inside, would be 20. And there's actually another way to do it as well, where you could solve for this angle here. If you remember your parallelogram, the law, like this 70 plus this angle down here has to add up to 180. So that angle is actually 110, which means I could then say this is actually 70, and I could use this angle of 70, and then I can do those sides. But you can't just use the 70 where they give it to you. We could also say if it's a parallelogram, if these are parallel lines and that's a transversal, well, then that has to be congruent to that because of alternate interior angle, that whole thing we did a long time ago. So there's a bunch of ways to figure out the angles you need inside, but the key is you can't use that 70 that's outside the triangle. It's got to be inside of the right triangle. And then once you understand that, it's just like the other trig problem we did where so now that I know this is 70 or that's 20, I label opposite, adjacent, hypotenuse. figure out where I need the information, where I have the information, and then I go through the same process I went through when we did example 2 or 3 or whatever it was. 2, I think. Any questions on that? I mean, we went through it fast, but it's recorded. I'm recording this fast. So put your stuff up. I'll give you the exit ticket. And once you're done, you can put your head down, use phones, whatever you want. I'm in such a good mood. I'm such a nice teacher. Nobody ever agrees with me. I wouldn't even say I'm a nice teacher. I want you to be successful, which means sometimes I have to not be so nice. I have to push you a little bit. I want you to be successful. I'm not sweet. I would not say I'm mean, but I'm not a sweet teacher. Like some teachers will just like they coddle you and they enable you and they like do things that I frankly don't believe are going to be helpful in the long term. You might love them to death for it, but I don't know that it's going to be helpful in the real world. Here they are. It didn't take very long. Well, if you were paying attention. Fantastic. You're just as good an artist as I am. This is literally stuff they had pissed it off at all. That's why I joke about it. Well, that's not your fault. Oh, it's my legs. So weird how those phones do that. There you go. No need to set a timer because you pretty much have as long as you need. Oh, yeah, I didn't pass the sheet out, so I'll write them up. Sine is opposite over hypotenuse. Wait, you don't need that. Yeah. You don't need that. There's not a trig, so that should be a hint. There's no trig necessary in this. I thought, what were you asking for then? Yeah. What? Don't need that, so that should be a hint. Now I know what your question is. Figure it out. Interesting to see how many people choose anatomy. What means learning. There.
Next.